Morning. Right, we're going to look at magnitude and direction of a vector. So we're aware that a vector has got magnitude and direction. So we can use the unit vectors I and j to help us find them, and the magnitude and direction. And because we work in the x and y directions, we're forming a 90-degree triangle every time. So the size of the unit vector A is written as the modulus of A. So we're going to try and find the magnitude of the vector 3i minus 7j. First things first, we need to sketch 3i, so 3 in the I direction, and then 7 minus 7 in the j direction. So we've got 3 across, and then minus 7, so we come down 7. So the vector 3i minus 7j is that one there. In order to find the magnitude of the vector, we use Pythagoras to find the size of this here. This goes across 3, that goes down 7. So this vector here is given by the modulus of our vector. So if we call this vector v, we can say the modulus of our vector v is equal to the square root of 3 in the x direction, so 3 squared, plus minus 7 squared. Now I've written minus 7, but it doesn't really matter because I'm squaring it, it's always going to be positive. So that gives us then the square root of 9 plus 49, which is the square root of 58. And when I work that out with my calculator, that's 7.62. So that's equal to, oops. There we go. Good. That's the modulus of v. Might want to write this down as an example. This time we're going to look at another example, this time to find the direction. So let's call this an example here. Always the best thing to do is draw the diagram. So it's minus 4i. So if we have our x and y axes, minus 4, so it's negative. So you start at 0 and go to the left. And 5j, so positive 5. So minus 4i plus 5j is thus. So we want to find the direction, the angle between the vector and the x-axis. So that angle there, from there all the way to there. But because I know this is 5 and this is 4, I can use this angle here to work out this angle and then take it away from 180 to work out the whole thing. So call that theta. I'm going to find theta. So I can say theta is equal to, well, let's use SOHCAHTOA. I know the opposite and the adjacent, so I'm going to use tan. Tan of theta is equal to opposite 5 over 4. So theta is tan to the minus 1 of 5 over 4, which is 51.3 degrees. So that's 51.3 degrees here. Now I need to find this angle here because that's what I'm looking for. The angle it makes with the positive x-axis. A straight line is 180, so I do 180, take away 51.3, that will give me 128.7. Got another example here. Let's change this to pen. There we go. So there's our example. Vector A has magnitude 10, makes an angle of 30 degrees with J. Find A in the column vector format. So it makes an angle of 30 degrees with J. So it makes a 30 degree angle with the y-axis. So if I draw it, that's my vector A. That's the size of it, is 10. So now I need to find A in column vector format. So I need to find across here is the x value, and then up here my y value, so I and j. So I can complete the triangle like so. So GCSE trig, that means I can use SOHCAHTOA. Now if I want to find this region here, this is opposite to my angle, and this is the hypotenuse. Opposite on hypotenuse is sine. So if I call this here x, I can say that sine of 30 is equal to opposite x over 10. Rearranging that, that means x is equal to 10 sine 30. When I work 10 sine 30 out on the calculator, that's going to give me 5. So x is equal to 5. I can call this y. Now y is adjacent to my 30 degrees here, and that's the hypotenuse. So I can use cos. So cos of 30 is equal to adjacent y divided by hypotenuse, which is 10, and y is equal to 10 cos 30. Work that out, and that gives me 5 root 3. So y is equal to 5 root 3. So it goes across in the I direction. So I can write A is equal to across in the y direction 5 and up in the y direction 5 root 3. And that's my column vector. Remember, we could write it as 5i plus 5 root 3j, but the question asks us to give it in this format. So we give it in that format. Good.